For Project 5, you will learn how to construct the basic geometry for a fixed gear bicycle. This geometry will act as an underlay for the solid geometry that will become your custom bike frame and fork and will be combined with all the other bike parts that you've designed thus far or will be designing in the future. Before we get started, we will discuss the key components that make up a typical bicycle frame. Shown here highlighted in yellow is the bicycle frame, and in blue is the bike fork. The frame consists of two triangles, the main triangle and the rear triangle. The main triangle consists of the top tube, the head tube, the down tube, and the seat tube. The rear triangle consists of the seat stay and the chain stay. The chain stay, seat tube, and down tube all converge at a cylinder which is known as the bottom bracket shell. Through this cylinder passes the axle for the crank. The seat stay and the chain stay meet at the back at the rear dropout. The rear dropout is a slot through which the rear axle of the rear wheel passes. At the front of the bike is the fork. At the bottom of the fork is the fork or front dropout, which is a slot through which the front axle passes. Rising from the dropout is the fork blade, and the blade on the left and right side of the bike meet at the top, which is known as the fork crown. Emanating from the fork crown is a tube which passes through the head tube of the bike frame. It is this steering tube that the handlebar attaches to via the stem. In this area of the bike, we have the seat or the saddle, which is attached to the seat post. The seat post is inserted into the seat tube of the frame. In order to design our bicycle geometry, we will be starting with a sketch like this one. We will be altering the proportions to suit our own personal needs. A small bike will be used for a small person, a large bike for a large person. But before we do this, each of us has to decide what is the appropriate frame size for our particular bodies. Traditionally, bicycles have had horizontal top tubes. The frame size was the measurement of where the top tube intersected the seat post down to the bottom bracket shell. Today, bikes tend to have sloping top tubes, and so bike manufacturers have maintained an imaginary horizontal line that the bicycle is measured from where it intersects the seat tube down to the bottom bracket shell. This also gives us a theoretical top tube length, which is known as the effective top tube. You will use these concepts when you are making adjustments to your bicycle geometry. Your first step in this process is going to be to determine the appropriate frame size for your bicycle. To do this, you've been supplied with a chart which has been taken from the Trek Bicycles website. For your particular height, you will usually have a choice of 3 different frame sizes. In a separate video, I will show how using your height and also your inseam length, you can choose which of the frame sizes is going to be appropriate. Once we've chosen our appropriate frame size, we are going to be going back to the sketch and deciding what are going to be the appropriate numbers to put into these various parameters. In order to determine those parameters, you've been supplied with 2 additional charts from the Trek Bicycle website. One is for women's bike frame geometry, and the other is for men's bike frame geometry. Included in each chart is a selection of frame sizes. Each frame size has a series of parameters, such as seat tube length or wheelbase length. Included in the chart in red are abbreviations for those parameters, which correlate with abbreviations that are included in the sketches that you've been given for Solidworks. For this example, we will use a theoretical person who's about 5'10" and has an inseam or leg length of 33 inches. We will see from a follow-up video that for him, an appropriate frame size will be 56 centimeters. We will then use this geometry chart and take this column of numbers and plug them into our sketch. Going back to our sketch, the first thing we will change then is the frame size, which we decided was going to be 56 centimeters. Then moving down the list of parameters, the head angle, which is abbreviated HA, is supposed to be 73.5 degrees. Seat angle, abbreviated SA, is supposed to be 73.3 degrees. The effective top tube is 56 centimeters. The chainstay, CS, is 41 centimeters. The wheelbase is 98.3 centimeters. The C-tube ST is 53.3 centimeters. And finally, the head tube from the chart is 17 centimeters, which is what we already have in this sketch. The offset, which we skipped over, is a driven dimension in this sketch of 4.08 centimeters, which is close to the chart, which is supposed to be 4 centimeters. Now we can see that the top tube has quite a bit of slope to it compared to the theoretical effective top tube. The important parameters that affect how a person fits on their bicycle will be the wheelbase, the frame size, the effective top tube, the angles of these tubes, and the length of the seat tube. Where the seat stay connects to the seat tube, or where the top tube connects to the seat tube, don't really affect how a person fits on the bike. For example, I can take this dimension here, move it up and down. We see the top of the seat tube moving up and down, and it has no effect on the rest of the geometry of the bike. Similarly, we can take this back end of the top tube and move that up and down. Once again, that affects no other parameters on the bicycle. We can even take the front of the top tube and move that up and down a little bit as well if we so desire. The other parameters that I mentioned I would not change by more than about half a centimeter, perhaps 1 full centimeter. And these angles here I would not change by more than 1 degree. Once I've made my adjustments to my frame layout sketch, the next step is to make an adjustment to the seat height and the handlebar height. That sketch is found here on the feature tree. Now you'll recall for our theoretical person, they had an inseam of 33 inches. We have to convert that inseam length to centimeters by multiplying by 2.54. That's about 84 centimeters. We want to take that length and multiply it by 0.9, which gives us about 76 centimeters. So that's what we're going to do to set the seat height. So the top of the seat is going to be 76 centimeters down to the center of the bottom bracket shell. The next step is to set the handlebar height. The handlebar height is normally measured down from the top of the seat. An aggressive racing bicycle will have a very low handlebar, which means that this handlebar height will be a large number, pushing the handlebars down. And a more relaxed geometry bicycle will have higher handlebars, meaning that this number will be small. So for an aggressive bike, we might make this 10. For a more relaxed bike, we might make it 0. Remember, this is just where the handlebars attach to the stem. Your handlebars will also have a bend in it, which, if you want, can bring the grips way up high or farther down low. But use a number of about 0 to 5 for a relaxed bike and 5 to 10 for a more aggressive bike. With the completion of this sketch, we now have all the important parameters adjusted for our bicycle, and we can go ahead and save this file, perhaps under a new name. The next step is to take your geometry and print it out, and then sketch directly on top of that various ideas you have for your frame and fort, using the printed out geometry as a guiding underlay. Although the lines in the underlay are straight, you can draw your frame tubes with curves or whatever shape you desire, provided that they meet at the critical points in your underlay and without altering your basic geometry parameters, such as was discussed before. Try out 2 or 3 different ideas, bring them to class, and also bring along a printout of the parameters you used that inspired your particular geometry. That's it. And don't forget, there will be a video after this one which will help you decide what is the appropriate frame size for your bicycle.